Let's practice some more differentiation involving e to a power. That's an exponential expression, e to a power. That's what, this is a little different than what we've seen before. But I'm, again, hopeful that as you inspect this one and look for the overarching operator, you would realize that we have 3x times e to a power. So again, this would be a good candidate for the product rule. Not just a good candidate, that's what you need to do. And I'll say this much, if that was just 3, you wouldn't need to do the product rule. It's just a coefficient times e to a power. But given the fact both factors have x in them, product rule, u times v. So again, the assumption we have to make is you remember that pattern. So to differentiate this, we would say, okay, each factor gets a term being a derivative. Remember our two daughters named Ursula and Veronica, u times v. So we leave the first one alone, then we differentiate that second one. And there again, just like the previous examples, the logic needs to be that that cosine x could be thought of as being an inside parentheses thing. So the chain rule would be, you do the e rule first, e to the cosine of x, all right? Then, because that's the outside operator, then you take the derivative of the internal one. So then you go, what's the derivative of cosine? Oh, that was on a slide that some nice man gave me before spring break, wasn't it? The derivative of cosine is negative sine x, and then to take it to its full extent, the derivative of x would be 1. Keep in mind, if that was a 5x, there'd be a 5 on the end. So again, maybe I should change the question to make sure you understand that. Make sure when you do the chain rule, you take it to its full extent, you work your way all the way in. We're not done though, are we? Because this one hasn't had a term being a derivative, so we go plus, I could keep going that way, I don't know. The derivative of 3x, which is simply 3, right? Each factor, each child gets a term being a derivative, and then the e to the cosine x has already had a term, so it just transfers down. In the product rule, this was u v prime plus u prime v. That's old stuff. We're just simply plugging a new rule in with all of our old friends, such as chain, product, etc. So, hit pause whenever you want to. In fact, that's what makes this probably better, is you can make the old man freeze anytime you want if things get going too quickly. All right. So, it just occurred to me, maybe we should give you a pause button when we're here in person. I don't know. Okay. Now, rewrite. Wouldn't you want to change that 5 over x into 5x to the negative 1 power, right? 5 over x. Let's use negative exponents whenever we possibly can. So I think that makes sense there. All right, I think this is a pretty simple one once you realize to do that rewrite. Notice the guy put prime, which means we're doing a derivative, right? And again, I like to think of the quantity that has x in it as being the internal operator. That gets my brain going in the direction of chain rule. So you go, okay, what's the external operator here? E. And what's the derivative rule for e to a power? E to a power. Cool. So, first step would be e to that very same power. You're done with the outside. Then you multiply that with the derivative of what's inside. Let's put in parentheses just to be sure it's multiplication. And that would be negative 5 x to the negative 2. Just a straight up application of the power rule. Bang, it's done. So I hope everybody's going, yeah, these are pretty easy, aren't they?
That was easy.
I think it is easy. Get it? Easy. Yeah, it's not very funny. Okay, but you know what? I'm entertaining myself here. Alrighty. I think we'll do 3 more on this slide and we'll be done with it. So, alright. Notice in the next example here, oh, I know what we need to do. We need to change those radicals into fractional exponents, don't we? Let's see, the 4th root of x would become x to the 1/4 power. And then we got minus, oh, so this is its own term. And then this would be e to the negative, there's a negative sign there, I don't know if you can see it. And cube root of x would be x to the 1/3 power. Now that negative didn't become part of the power there, did it? It was just sitting in front of it. So that's an important thing. That's not x to the negative 1/3. It's negative x to the 1/3. So be careful with things of that nature. I'm hopeful that you'd look at that and go, that's easy. That's just a couple of terms. Do you guys remember what we use for that? What's the derivative rule for terms? Linearity, matey. That's right. So, each term, e to the power times the derivative of the power. 1/4 x to the negative 3/4. That would all be the derivative of that, chain rule, e to a power, derivative of the power. We get the pattern. That's what you do when you see e to a power. Minus, same thing, e to the power, e to the negative x to the 1/3, times the derivative of that power itself. And that's just power rule. Negative 1/3 x, let's see, what's 1/3 minus 1? Negative 2/3. Yeah, it hurts me if you perform your subtraction wrong and get that very last power wrong. In essence, the whole question is supposed to be counted wrong. Just be careful with details like that. 1/3 minus 1 is negative 2/3. I've shared with you guys many times that the majority of mistakes that I see are arithmetic and algebra. Subtracting wrong, getting that final number incorrect. And it's sad, but, I don't know what else to say. So, whoops, just like that, I miscopied the question. Okay, again, a lot of this is recognition of what the algebra structure would be for the question. In other words, what's the overarching derivative rule? Hit pause if you want to, I gotta make room. Okay, well, I hope you're looking at that going, oh, you know what? Let's see, I hear Aretha Franklin, don't you? Chain, chain, chain. Sorry, Aretha, I'm trying. But wouldn't sign be the outside operator? Sign, that's not multiplication. That's the sign of what's in the parentheses. Again, sign would be the external operator. So we start with that. Let's see, what's that derivative rule for sign? Some really nice guy gave me a slide that had all those rules. Oh, that's cosine. Yeah. Okay, so that'd be cosine. That's the derivative rule associated with sine. Let it be. Just copy these down. Remember when you do the chain rule, you leave the inside one alone. Then you do the derivative of internal. Oh, those are both terms. Linearity. Let's see, e to the power, e to the 3x minus 2, times the derivative of 3x minus 2, which is 3. Let's just put 3 in parentheses. If you want to put the 3 in front, I get it. But I was tacking on the end just to help people remember that the sequence was that occurred after. Then we have minus, e to a power, e to the negative 4x, times the derivative of negative 4x, which is negative 4. Yes, you could pull that up and make it plus 4. And then let's close it off. And that would be the derivative of what's inside. Woo! All right. So we're getting a good workout here on our old friends, chain, product. I probably won't hit you with quotient, though I could. And then, all right, our final one on this particular slide. Okay, e to the negative 4x minus e to the 5x, all to 1/2 power, isn't it? Rewrite. You see radicals, you rewrite. And again, because of the subtraction, you can't somehow apply it to each one. So we got to leave that quantity as is. Here we go. Let's see, I hear music, don't you? Yeah? Oh yeah, chain. Outside, inside. We start with the external. What is it? It's a power. We start with its derivative rule, which would be power. Bring it down, subtract 1. Wouldn't that be 1/2 here, negative 1/2 here? What do you do with that? Let it be. carry it down, cover up that outside. Chain rule, go back, review it if you need to. And then the inside we have terms. Linearity, we do each term. E to a power times derivative of power. I'll remind you again, that would be chain rule going on that particular term. Minus e to the power times derivative of the power. Boom. And that would be the derivatives of those respective terms. I think that takes care of how to differentiate things, functions involving e to a power. We will transition now to the slide that has example 2, and we'll introduce the rule for finding the derivative of natural log. All right?